Yo, what's up guys? The purpose of this topic is to teach students how to identify, describe, and draw and analyze histograms properly. It is imperative to understand how to draw correct conclusions from histograms, graphs, and data.
A histogram is a graphical display of the distributions of data using bars of different heights. We also use histograms for univariate numerical data. Histograms used with numerical data include discrete data and continuous data.
Discrete data uses categorical and continuous uses numerical. The rectangular bars represent the frequency or relative frequency of each data, with each bar grouping numbered into ranges. The taller bars show that more data falls into the ranges, hence representing a higher frequency or relative frequency.
That's right, Dawn. And what else is the frequency of a data category is the number of data points falling within that category, while the relative frequency is the proportion of or percentage of data points in that category relative to the total number of data points. Thus, the total area of all the bars in a histogram with relative frequency is equal to the total number of data points, or 100% when using relative frequencies.
It is important to choose the correct width for each bar when constructing the histogram, because if you go too wide, you oversimplify the data, whilst going too narrow can lead to excessive detail. You can usually find the appropriate bar width by square rooting the total number of data points and rounding it to the nearest whole number.
The density on the y-axis, that's the chance of obtaining values near corresponding points on the x-axis.
The x-axis of the histogram represents the data of categories or intervals, while the y-axis represents the frequency or relative frequency.
Histograms can help identify outliers in a data set. Outliers are data points that fall outside the typical range of values and may significantly affect the shape of the histogram. If a value is more than 1.5 IQR, it is considered an outlier. It is also important to note that any gaps in a histogram, as it is another form of an unusual occurrence.
If a histogram is symmetrical, the mode coincides with the peak of the distribution. The mode is the interval with the highest peak of the distribution.
If the distribution is clustered around the right tail when the left tail is longer, it is skewed to the left. This means that the mean is less than the median, and the mean underestimates the most common values of the data set.
If the distribution is clustered to the left, with the right tail being longer, this means that the mean is greater than the median, and the mean overestimates the most common value, and it is positively skewed.
The number of humps or hills determines the model of the distribution. A histogram is unimodal, or most commonly known as bell-shaped, if there is only one hump, and bimodal if there are two humps, and multimodal if there are more.
When you cuss a histogram, it is important to identify the center, unusual occurrences, spread, and shape so you can give the most accurate and in-depth analysis for the graph.
The first example we're going to do is a discrete example, and Jonathan's going to read the problem.
Queen honeybees mate shortly after they become adults. During a mating flight, the queen usually takes several partners, collecting sperm that she will store and use throughout the rest of her life. A study on honeybees provided the following data on the number of partners for 30 queen bees.
So given the data right here, we're going to put each number into a group. And since it's discrete, we don't do ranges, we do individual counts. So we count up all the number of ones, in this case we just have one. We count up all the numbers of twos, which in this case is also one, threes, also one, and so on and so forth. After you put all the numbers together, then you're going to graph it on the data based off the frequency. Since we only had one of number one, we're going to draw a bar one right there to the first line. We're going to want to make sure the one is in between the bar, and then you're going to continue that for the rest of the data. So now that we have our histogram drawn, we can cuss the data. When we cuss, we talk about four things. We talk about the center, unusual occurrences, center, spread, and shape. This histogram looks to be unimodal with one hump. And it also looks to be approximately symmetrical with no unusual occurrences or outliers because there's no gaps. As for the center, we can say the center lies around 7, being the median, and that the mean is around 7 and 8.
What's good, gang? We're back with our continuous graph. Let's get it started, Johnny G.
You heard the man. Mr. Larry, a famous doctor, is researching the height of the students studying in the 8th standard. He has gathered 15 students but wants to know which maximum category is where they belong. Draw a histogram and cuss it.
I got you, JC Money. Let's get started here. Let's show our axes. We got our y-axis and our x-axis. Let's show this a little bit taller. Okay, so let's label our ranges. Let's look at this. Let's think. What should our ranges be? Should they be 0 to 200? No, they should start at the minimum first. So our first range should start at our minimum, which appears to be 138. So our first range is going to be 138. Now, me personally, looking at this, because I have advanced computing skills, I think the range should go from 138 to 140. So let's do that. So that's one range of numbers. So this range of numbers, let's see how many times it's repeated in the table. Let's just do a little, little 1, 2, 3, 4 action here. 1, 2. This is the frequency. So let's label it. This is the range of values. So 138 to 140, let's count it. No, no, no. No, 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 no. We got 1. And that's it. So let's get it to 1. The height represents the frequency, so 1. Now, let's do that for all of them. So now we're back here. The most important thing to remember is that the ranges should not overlap. So we have brackets for inclusive and parentheses for non-inclusive. And that's how we get all of these. And also remember is the widths need to be as same as possible, because having a smaller width might indicate a lower frequency, which in fact is not the case, because frequency is represented by the histogram's height. I hope you learned something today. If you didn't, you're kind of dumb. But anyways,
We'll catch you later. Thanks for joining us.